Welcome to Astronomy Part 3. Today we're going to be talking about the physics used in astronomy, the technologies used in astronomy, and how it impacts society and the environment. First, we need to understand how physics and astronomy are related. Well, physics is the study of laws of nature, although astronomy is the science where astronomers examine physics used around the universe. Astronomers use physics to understand what they're seeing in all pictures that come off the telescope. Speaking of telescopes, they're one of the most commonly used technologies by astronauts and astronomers. Telescopes are diverse instruments that look similar to unique-made CCD cameras with various filters involving a photometer and a spectrometers. This technology is designed to detect what we cannot witness with our eyes. In a reflecting telescope, instead of a convex objective lens, a concave mirror is used to collect parallel rays from the object and form an image at a focal point. Then, the convex eyepiece lens is used to magnify this image for the viewer. Mirrors are used instead of lenses in large professional telescopes. This is because an objective lens can have a maximum diameter of approximately 1 meter before it begins to sag, whereas a mirror of several meters in diameter can be used. Another technology used by astronauts is a transmitter and a receiver. Messages travel through space as radio waves. These radio waves work very similarly to how radio waves on Earth work. Each spacecraft has a transmitter and a receiver for radio waves, as well as a way of interpreting the information received and acting on it. Radio waves from a spacecraft need to be received on Earth. However, they're quite weak when they get here. These must be precisely aimed so that they can get the waves. Likewise, NASA must precisely aim transmissions to the spacecraft so that these ships can hear the messages. Now I'll be talking about the electromagnetic spectrum. There are 4 forces that exist in the universe, also known as the strong nuclear force, the electromagnetic force, nuclear weak force, and the gravitational force. The strong and weak nuclear forces both exert their power in very short distances, and they rarely impact our daily lives on a daily basis. That leaves us with the gravitational force and the electromagnetic forces in the universe that impact our daily routines. Electromagnetism arises from the property of charge, while gravity arises from the property of mass. If a charge is stationary, electrostatic fields revolve around the charges. However, if the charge moves at a constant velocity, it creates a magnetic field, and as it accelerates or decelerates, it produces electromagnetic radiation. Electromagnetic radiation is a combination of the swinging of electric and magnetic fields that travel through space with a velocity of 3 times 10 to the power of 8 meters per second. The electromagnetic spectrum has a wide range of frequencies, starting as low as 30 Hz to 10 million Hz, with wavelengths smaller than the nucleus of an atom. The electromagnetic spectrum has been used for many years as a way of communication through electromagnetic waves. The lower the frequency, the more distance it travels to Earth before it loses its power. The technologies I just talked about right now are just a few technologies used by astronauts and NASA. There are hundreds and more technologies used every day by these astronomers or astronauts to get a better understanding of the universe. Even though these technologies have helped us for many years to get a better understanding of the life outside of Earth, they've also created some environmental problems not only inside Earth but also outside Earth. For example, they've caused many space junks, and even though you might think that space junks don't really affect us because they're in space, they really do. To begin with, we have to think about what a space junk is. Well, space junks are also known as debris, and they're made up of used up rocket stages, loose fragments from rocket explosions and collisions, launch canisters, dust and paint flakes, even objects that are usually lost in the space such as cameras, garbage bags, wrenches, pilers, and even an astronaut's glove are now a part of this litter that we have caused. Now you might think, how are space junks dangerous to us? Well, when an object gets lost in the space, it starts to travel at 6 miles per second At this speed, the tool is so dangerous in space. If it collides with a space vehicle containing human passengers, it could create significant damage that could threaten the life and safety of those on board. The collision can also lead to more junk to be released into space, creating more risk. The bigger the spaceship is, the higher the risk of colliding with the space junks. So now I'm going to be talking about some statistics to give you guys a better understanding of how much damage we have caused in the Earth's orbit. According to ESA, the number of rockets launched since the start of space age in 1957 was about 5,250. The number of these still in space is about 4,300. The ones that are still functioning are about 1,200. The number of debris objects regularly tracked by the U.S. Space Surveillance Network is about 23,000. Total mass of all space objects in the Earth's orbit is about 7,500 tons. That means 29,000 objects per 10 centimeters. While these numbers are increasing every day, we must think of a solution for this problem and take care of it as soon as possible. Lastly, we must think of how society relates to astronomy. Well, in the past, astronomy had been used to measure time, mark seasons, navigate oceans. As one of the oldest sciences, astronomy is a part of every culture's history and roots. It inspires us with beautiful images and promises us answers to the big questions. It acts as a window into the immense size and complexity of space, putting Earth into perspective and promoting global citizenship and pride in our home planet. So what must we do? We must gain knowledge about astronomy and try to find ways and solve environmental problems related to this science while being able to learn about everything in this universe. Thank you for watching this video. Goodbye.